Okay, so how do you solve statics problems? Well, it's a very easy procedure. All you have to do is look at the sum of all the forces in the x direction, set that equal to 0. Look at the sum of all the forces in the y direction, set that equal to 0. And look at the sum of all the torques around some pivot point that you can choose. Only in statics problem can you choose it. And you set the sum of torques equal to 0. So, for example, you can imagine that you have some bar that's attached to a wall, and let's say that there's a force up at the end of this, say, 2-meter long pole, and this is going up at 3 newtons, and let's say there's a force going down at 6 newtons. And what you want to find is you want to find what's the force that the wall is putting on this. And we don't know, let's say it's either up or down, and so let's call that F question mark. And I'll say that it's up, but if we get a negative sign for it in doing the calculation, then we know that it should have been down. So to find this, what we can do is we can use our equations over here. You won't always need to use all of the equations. You might need one, you might need two, you might need all three, depending on what you're looking for and what you know. So in this problem, we know that we don't need the x equation. So there's no forces in the x direction, so we don't need that. But we do need the sum of the forces in the y direction. So let's write that out. Sum of forces in the y direction are equal to, well, there's a positive force of 3 newtons, there's a negative force of 6 newtons, and then plus, oh sorry, this is negative, plus our force we don't know. And we just set this equal to 0, and what that means is force question mark is equal to 6 newtons minus 3 newtons equals 3 newtons. So it turns out we only needed to use this one equation, just the forces in the y direction. Now, we could have also used the torque equation. And so just to check that we did this right, let's use our torque equation and let's choose a pivot. So you usually want to choose a pivot where maybe you're turning, because that way you don't need to worry too much about what's going on in F question mark, but we're looking for F question mark and we want to use torque. So let's choose a pivot where that isn't at the point of application of F question mark. So it'll be in our expression for torque, and that way we'll be able to find it. So I'm going to choose a pivot point that's over here. Let's say it's like 1 meter to the left of where it's attached to the wall. And so what are all the torques around this point that isn't even on the bar? You can do that. You can put the pivot point anywhere when you're doing a statics problem. So the torques here are going to be, well, our F question mark up, F question mark, times the length of the lever arm, which is 1 meter, plus, well, from here to here is 2 meters, so we have a 2 meter lever arm to our negative 6 Newton force, and then we have a lever arm of 3 meters to our 3 Newton force, so that's plus 3 meters times 3 newtons. Okay, so we set this equal to 0, and then we find that F question mark is equal to 12 Newton meters minus 9 Newton meters, and that's equal to 3 newtons. So we got the same answer for the question mark force doing the y, sum of y forces and the sum of torques. So hopefully that should help you in solving statics problems. Sometimes you'll need to use all the equations and solve a system of equations,